Lucia. It's quite intimidating standing in front of all of you, but before I start, I would just really like to thank all the speakers during this session. They've really made my job a little bit easier by emphasizing the importance of monitoring, and a special thank you to Nazreen for giving such a thorough description of the study site that I'll be focusing on. It has really made my job a little bit easier. What I will be presenting to you today is progress on a pilot study that is aimed at informing a long-term water quality monitoring program within Lake St. Lucia to help us try and understand global change impacts. Now, with global change impacts, I mean both land use and climate change impacts. And so before I start, I really need to emphasize that this work forms part of a collaborative effort between the South African Environmental Observation Network, Department of Water Affairs, Ezemvelo Wetland Park Conservation Authority, Ezemvelo, KZN Wildlife, and then a number of independent academics. So obviously, as you've already heard today, the St. Lucia system is a very important system for the country. Concern was raised due to the cumulative impacts of human activities within the system, and in response to this, various management interventions has been stimulated to try and ensure the health of the system. All these management efforts have been well documented, and as our understanding of the system improves, obviously our management interventions also improve. Active research in this system has been conducted since the 1950s, and this has really helped us to have a reasonable and conceptual understanding of the estuarine functioning, as well as it has helped to develop a body of data which one can draw upon in order to inform long-term monitoring programs. So this has provided a nice platform for trying to develop a long-term monitoring program in order to try and inform and understand global change impacts. So the big challenge that SAEON faced was, what are your key non-negotiable variables that needed to be measured and monitored in the system in order to really inform a long-term monitoring program, and then obviously the where and the when. So luckily, the perks of working in a well-documented or well-studied system is that you have a lot of available information to draw upon in order to inform your monitoring efforts. Dr. Ricky Taylor was the first to integrate all the available information obtained through a long-term monitoring program, the various independent studies within the system, and then obviously expert local knowledge. He then developed a conceptual model that helped to identify various components that needed to be addressed in future to help improve our understanding of the ecosystem functioning. One of these components that wasn't identified was the physicochemical variables and some water quality variables. These components and parameters were basically reiterated, the importance were reiterated by the Ezemvelo Wetland Park Authority, Department of Water Affairs, and from what we've just heard, obviously DEA as well, and then obviously various academics that requires this baseline information in order to help refine their process level research. And I believe what we're hoping to achieve will fit in nicely with what Nazreen is also trying to do in the system. So seeing that we had pretty much a good idea of what we needed to sample in the system, the when and the where was still a big issue, so that's why SAEON, in collaboration with the Department of Water Affairs, have initiated a pilot study in June of this year. The aim of our pilot study is to try and develop a comprehensive baseline data set on the physicochemical parameters and some other water quality parameters that will be used to help to define and inform and develop a long-term water quality monitoring program to help us to understand global impact change in the system. As well as we would like to determine what's the variability of the physicochemical variables on a spatial and temporal scale. So obviously, because the site description was done so well by Nazreen, I'm not going to go through that. So we have conducted 2 reconnaissance surveys in 2013 to try and find out where exactly we need to monitor these various variables. So based on our results, we selected 26 sites along the length of the system. This entails the 14 historical sites as researched by Pillay and Perissonato in 2006 and defined by them, as well as 5 sites at the main river inlets, as well as then 7 novelty sites. We really tried to get a spatial representation of the system, obviously given the logistical challenges and also dependent on accessibility of the system. So we've adopted a 3-phase approach. So phase 1, obviously, like I mentioned, has been completed. So we are currently in phase 2, where we've implemented the pilot study. So standard materials and methods were used as described in the National Estuarine Monitoring Program by the Department of Water Affairs. This is basically just a summary of all the data that we have collected thus far, but because of time limit, I'm only going to focus on a subset of the data. I'd like to emphasize that I'm in no way trying to define or describe the functioning of the St. Lucia system. I'm just trying to give you a sneak peek of some valuable and interesting results that we have found thus far. Okay, so the study done by Perissonato and Pillay in 2006 summarized basically the salinity range within the drought conditions, and obviously, as we all know, that the St. Lucia system was in a state of high salinity at one stage, and salinity values of up to 216 parts per thousand have been recorded in the system. However, just focusing on my graph, the graph is a representation of our 3 sampling efforts. I've designed the graph in such a way that we start down at the mouth, and it basically works its way up along the length of the system to the Mkuzi river mouth. So what I'd like for you to focus on here is that there are 2 key aspects that came out from our recent surveys, is that this, number 1, Lake St. Lucia is not as saline as it used to be. It's not as hypersaline as it used to be. And number 2, just looking at the differences between the 3 different sampling efforts, we can already see that there are major variability with regards to spatial and temporal variability. Now, if you're anything like me, I need pretty pictures to make sense of my data. So I have created these graphs, which just to represent the spatial variability as well as temporal variability of the results obtained through our various sampling trips. The blue represents low salinity, whereas the red represents high salinity, which can go up to 35 parts per thousand. Obviously, the key drivers influencing salinity levels in Lake St. Lucia is your mouth state, rainfall, and evaporation. And here you can see when this Lake St. Lucia was still open to the ocean via the beach spillway, high salinities were found within the estuarine region, whereas when this connection was closed off during June and August, you find that reverse saline pattern as documented in historical records. Okay, looking at the temperature, nothing really special there except that it's following normal seasonal patterns. However, the reason why we are very interested in monitoring temperature, especially over a long term, is to try and see if we can't pick up any directional change towards the global change impact, and then obviously aids in understanding global change in the bigger context. Dissolved oxygen. Again, all I like to emphasize here is that you can see the system is fairly well oxygenated throughout the length of the system. Looking at the spatial representation, once again, you have huge variability over time as well as space. We are currently exploring the link between wind and temperatures, a key driver with regards to the solubility of dissolved oxygen gas in the water column. But from what we can say so far is that wind's definitely, obviously, a huge driver in the system. Okay, pH. I would just like to, if you can see, most of your pH variables falls within the acceptable range for estuarine and marine waters. However, I'd like to focus your attention to the Mpati site specifically. As you can see, as you move your way away from the mouth towards Mpati, the pH level seems to drop. But as soon as you move away from the Mpati towards the northern section, your pH starts increasing. So this really made me think of what can this be, and I think that this acidic water is attributed to hydrogen sulfide being released from the anoxic sediment, and therefore decreasing the pH value specifically at this site. This just basically emphasized the importance of having a monitoring program that's spatially representative of your entire system, because an anomaly like this might have not been able to, would not have picked it up if our sampling regime wasn't so intensive. However, if you have to think about the bigger context, St. Lucia being such a big system, this punch might be absorbed throughout the length of the system. However, it still might be a system, still might be a site that we can include in a future long-term monitoring program. Okay, so as I mentioned, Pillay and Perisonotto helped to define 14 sampling stations that they went out and monitored on a regular basis. So based on the results found from February 2005 to May 2011, they applied a basic cluster analysis based on only the physicochemical data, and their outcomes showed that from their 14 stations, 5 broad clusters were identified. From those 5 broad clusters, 1 representative station was selected for future long-term monitoring and is indicated on this map. Mouth is Ngeni, Catalina Bay, Charters Creek, and then Lister's Point. Working with my first set of data, which consisted of the 23 sites across the length of the system, I ran similar analyses, and I actually found that where they previously found 5 different clusters during the dry phase, I actually found 8 different clusters during the wet phase, which makes us wonder how to go about defining sites for future monitoring, as there's distinct differences between your wet and your dry cycle. Obviously, first thing that comes to mind with the phytoplankton biomass is what's happening over there. All our chlorophyll A biomass analyses are done by Department of Water Affairs. We also collect water samples for cell counts. These 2 sites actually had the lowest cell counts in comparison to the rest of the system. Therefore, even though the concentrations came out 0, it might just be that the concentrations present in the water was just below their detectable levels. However, I don't want you to focus on the actual values. I want you to once again focus on the spatial variability along the length of the system. Perisonotto et al. Conducted a study where we actually looked at the spatial variability of the phytoplankton biomass within the St. Lucia system, and he found that there were 2 dominant entities, and the South Lake, Narrows and South Lake was combined as one entity, and then obviously False Bay and North Lake was combined as one entity. From my results, you can see that if you look at the phytoplankton biomass, we are finding similar patterns as they found during the dry cycle. Now looking at phytoplankton community composition, 3 main dominant groups were identified during the June sampling period. Obviously, up in the corner, your blue-green algae, your flagellates, and your diatoms. Obviously, you can already see that there's very distinct spatial variability across all the sites again, with some community compositions being more dominant in comparison to the rest. So once again, I just applied a very simple statistic just for exploratory analyses. It's not hardcore stats, just to see whether there will be distinct groups again. And yes, 3 dominant clusters were identified based on their association with the different community composition. So in conclusion, so what do we actually know? And from our reconnaissance survey, it was really useful to actually identify, with regard to logistics, what works and what doesn't. Obviously, one of the outcomes is that we really needed a bigger boat to handle all the variability with the weather conditions up in False Bay and North Lake. From what we've seen so far, it's really improved our understanding of the variability in the partitioning of the system, taking into account season, taking into account the wet versus the dry cycle, and we definitely can incorporate all of this information to refine our future site selection. From what I've hopefully been able to illustrate to you, that there's a distinct community assemblages just found after one trip. And we are really excited to see whether this will actually be a fixed spatial thing in the system, or is it basically going to change over time? And I know I've just basically briefly skimmed off the results, and I haven't gone into detail because my aim today was just to basically show you this very interesting and valuable information that we've already started picking up in this pilot study, and therefore I cannot emphasize enough that pilot studies such as this one that we're currently undertaking is very valuable in directing long-term efforts. So the way forward, where from now? Well, we still have 2 more field trips to conduct before the end of this pilot study. From there, we will complete all our data analyses and then compare what we find with the historical data and other data sources, and then hopefully use that to help direct us in informing a long-term water quality monitoring program for Lake St. Lucia. We will then go ahead and present our data at a workshop, because we'd like to inform the broader estuarine community of what we are doing in order to create a multi-institutional approach to ensure that all information being collected in this system is integrated as one, so that we have a more holistic idea of the estuarine functioning, because obviously, as has been emphasized today, working in isolation doesn't help. Okay, and before I end my talk, I really need to acknowledge the following institutions and individuals, because without their support, this project would not have been possible at all. And before I end off there, I really feel it's necessary to highlight the importance of these pilot studies, not only with regards to informing long-term monitoring programs, but also with regards to capacity building and skills development, as this pilot study has been very valuable to our interns for their internship with SAEON for the year. Thank you.
Thank you very much. You take a breath now.
I tend to do that.
Right, can we open up the floor for comments, discussion? Can we start with the front? Sorry, not discriminating against the background.
Thanks, Monique. Very interesting, and of course, we have vested interest.
Yeah.
I was actually wondering about the cyanobacteria.
Yes.
Do you have any idea of what it is?
I know Scott Deployed just published the paper recently, and it's exactly the same. It's the same one.
He's actually looking for those.
Is he? Then put him in contact with me, because we have some interesting results to share with him.
Collaboration is better. Scott.
Thanks, that was very interesting. I think what you said was a tremendous amount of variation, but it started 2 years before when it was 80% dry. And the scope of variation is incredible. It's the largest estuary system in Africa.
Yes.
And we have managed it in the past, but it's in an incredible state of flux at the moment. I think you're finding that 2 years earlier it would be fantastic, but as it is, it's really great.
Yeah. Thank you.
The monitoring is becoming more comprehensive as you go on.
Yeah.
Everybody involved. I think it's going to be really useful.
Thank you. We hope so. We hope so too, because we've invested a lot of time and money in this, and long hours, and putting your arm in the water when the crocodiles are just there and the hippos. So yeah, we really hope that this will make a contribution to our understanding of the system, and just help us understand everything.
Question. Thank you.
I noticed in one graph you had a lot of blue-green algae that was sort of further up.
Yes.
There was on the treaty side.
That was actually very interesting. I wasn't sure if I should hold back these results or not, because the blue-green algae was actually only picked up in the North Lake, because we have 5 sites across North Lake and 7 sites across False Bay. And in False Bay, the flagellate euglena was basically blooming, and it was the dominant species throughout, whereas you had these distinct differences between False Bay, North Lake, that's just next to it, where the blue-green algae was basically the dominant phytoplankton species. What this really means at the moment, we don't know. All I know is that they are both indicators of eutrophication, although previous nutrient results that we had analysed from our reconnaissance surveys actually shows that the nutrients available in the system at the moment is quite low. But whether that has changed now during our pilot study, I don't know. We still need to analyse those results.
So that could possibly be difference in graph analysis.
Yeah, exactly.
The other question answer that. Have you noticed, and I'm not sure if you've qualified to answer it, have you noticed any stromatolites in that?
No, actually not. As far as I understand, stromatolites, maybe Prof. Bate might be better to answer this. Sorry for directing the question to you, because I know this is a new up-and-coming topic that they've recently been found in the PE, and our Dr. Tommy Borman, our Wildlands node manager, did actually go out and show me these things. I have not noticed any similar habitat assemblages next to the areas where we're sampling, so unfortunately. Yeah, but we will look.
Yeah, because Bruno is involved in another project down.
Okay.
Question here?
Following on from both questions, really, what's the amount of nutrient flux going through from the sediments and might be released after drying the instead of directly now manifesting through? Is that something that you're looking at?
When we did our reconnaissance survey, we predominantly only focused on the water column, and when we took our results to various stakeholders, the one thing that jumped out is why are there low nutrients in the water, why is the phytoplankton chlorophyll A biomass so low? So that resulted in us adding the variables, and we are at the moment sampling for microphytobenthos chlorophyll A, as well as species composition, and we're collecting samples for nutrient load analyses and salt load analyses to actually find out where's the nutrients, what's happening to it. So those results still need to be analysed. So at the moment, I cannot give you an answer of where the nutrients are in the system, but we are trying to cover our bases with regards to the standard water quality variables.
Have you got any ideas, no?
Yeah.
Certainly the phosphates are under sort of anoxic conditions going to be released, and if you are getting anoxic, the water's up to the top end, you will actually get that bioavailable phosphate actually coming into the water. And it's been accumulating there over a long dry period. Sort of locked up and immobile. It could not be being released immobile, but it's cycling through the sediments into the water bottle to show that.
The only site where we actually picked up at hypoxic levels was again at Mpati, which just emphasizes and strengthens the discussion that spatial representations of systems are really important, and that might definitely be a site to include in future long-term monitoring programs.
There's a question at the back.
Thanks, Monique, for an interesting talk. I didn't see a monitoring point in the northeast of the system. Is that purely logistical?
Well, we're not allowed to access it. It's wilderness area. So we tried to sample all of the historical sites. However, sites where we weren't allowed access, we tried just to get a site across the original site in the area that we are allowed to actually access. Hence why we don't have representation on that side.
Just some comments. So we're not a research organisation per se, we're a monitoring organisation, and we really do welcome input and interpretation of this data, and we hope that the researchers come up and say anything that will help you assist in process level research, and if we're not experts for Monique.
No, hardly.
So just an invitation to people who see this information as valuable, and any advice, please come and approach us. And we are hoping that if the value of this is recognised by the various authorities, that we might be granted access to do further surveys on the eastern side, because, so supporting that.
Thank you very much.
Thank you.
The organisers have kindly allowed us some time before you are allowed to eat to have some discussion, and I think the discussion has been really lively, and I really appreciate all the interest from the speakers. I think we've got some really good quality input. We've got massive knowledge and wisdom in the room. And I was just wondering if we could pull out some salient points from the discussion here. to my mind, as sitting here as a non-estuarine person, everybody's saying the same thing. Is nobody really contentious about saying, wow, estuarine research is rubbish, scrap it all? Everybody realizes the importance of estuaries and the importance of monitoring. What I did pick up, and again, this is as an outside person, is the scales of resolution are different for different stakeholders. From the DIA perspective, it's on a national scale. We've got a provincial drive from Ayandastorp, and we've got process-driven scales of resolution. And obviously the temporal side is very important for, as you're saying, the directionality of change in the system. And I was wondering if there's somebody who can synthesize this for us really nicely in terms of how to go forward with this. And any other inputs and comments that from the floor, would be really appreciated. I'll try to scribble a few pointers, and this will go back to the organisers, because I think this is a really, really important session that we've just had, and it would be nice if we could galvanise some cohesion at least going forward. So any comments on what we've heard in terms of the data, in terms of the process going forward, I think would be really appreciated.
Could I just start with the comments about, there's a lot of work that's being done at the moment through the reserve determination processes for a lot of these estuaries and micro-estuaries up the KZN coast. There are also some estuary management plans that are being developed for some of our estuaries. But a lot of it is being done somewhat out of context of what has been done historically, and there's been a bit of a monitoring gap. So there's a huge uncertainty in a lot of these processes that are going to become enforceable and support regulation going forward. And I just think we have an opportunity, I think, now to identify this need and to try and coordinate our efforts to fill in that monitoring and understanding gap. So maybe that's just a comment as to the time is now that we step up and start identifying these issues of uncertainty in these gaps.
Yeah, following from that, I think it's important to note that different people are monitoring for different reasons. I think certainly what we've picked up in the solution system is a lot of the focus is on conservation. But we came in from the perspective of we're interested in all systems in the country, and we're interested in detecting global change impacts, and how do we do that? And studying well-studied systems helps in that process. So we took the approach of what are the non-negotiables that will help everybody in kind of understanding it. But I think, I can't synthesize anything, but I think we need to identify the key reasons why monitoring takes place. And then to actually, for those who were in the plenary this morning, we listened to the CDC, the WEN approach, where they identified the different service menus, as it were. The zero specialists of what and who's best suited to do what you want. And that kind of is a framework for, which, I mean, completely different topic, but it's a nice framework. I like the service menu idea in terms of sort of distilling the key reasons why monitoring is needed. And then understanding which are the key fields of speciality across the different government organisations to pull it together in a coherent, coordinated system. And there are initiatives that government realises that there's disconnect, and they are trying to pull it together. A push up would be good as well.
I think just leading on from that, everybody's talking about great people, but I think it has galvanized to some extent the thinking that we can actually do something that is deemed to be absolutely possible. Get the right people, squeeze every little bit that you can out of them. You can come up with a plan that will make a difference. I saw that the health aspect of the operation has kicked off. I think they'll be finishing up sometime soon. And so thinking has changed. I think at the government level that we can actually do something. It's not impossible. And I think even as a smaller grouping. And saying, I think the time is right for us to start pushing for a more cohesive approach. And I was just wondering, listening to all the talks and all the efforts going on, I wonder how many sampling trips have passed like ships in the night next to one another. And if you have one sampling trip that will service 7 or 8 different groups, I think the economy of scale might just be worthwhile. And instead of 7 people having votes on the system.
The discussion in St. Lucia is definitely going towards that sort of streamlining, building the economy.
Who would be the driver of this synthesis approach? So before we get to
the next session, by the way, one of the aspects that we'd like to discuss is the formation of a stakeholder group who's particularly interested in freshwater and estuarine ecosystem research, conservation, stakeholders. So it's something that initiated early on this year, but we didn't have enough of a representation to get an idea of what we should do, where we should go. So one of the discussion points that we're going to have in the next source to seed session is actually, is there a need? You should be doing it. Why should we be doing it? And really, it really is just the source to seed concept of and especially estuaries, being that conduit between freshwater and marine environments. We so often bumped our heads on trying to advocate what is good for an estuary out of context of what is good for the nearshore, and especially the Together case study, the Together Basin. So we need to start getting that buy-in from those different catchment side and then also the marine side. So we have to think outside of the box of not just focusing on estuaries. And we're very important to service both as well. So I think we've got a lot of opportunities.
Just before I take your comments, I was asked to just emphasize that after the signing to see and the Gerber to see, we've got the source to see. Special session after after lunch. So while you're chewing and ruminating, I've heard the source to see talk on KZN rivers. Because I think, as I was saying, that the linkages cannot be ignored. And I think big science paved the way for us to stop looking in the reductionist approach and start really synthesizing up to the systems level. So I think the time is right. And I just
Yeah, this was an add-on to what you were saying.